Good evening, everyone. It's Niall McGorn here from Lely Mullingar and Lely Kilkenny, and you're very welcome to our webinar this evening. We're well into the 20s now, so we've covered all aspects of robotic milking and farm automation. And tonight we have a particularly interesting lineup. We're going to be joined by Bertie Troy, who's the MD of Grasstec, that very well-known company from County Cork. Bertie's over 30 years in business, and looking at my notes here, he's providing farmyard design services, mapping of farms, supply of livestock, agri recruitment, and in recent years, precision ag. So it's a very well regarded and well respected business dealing predominantly in Ireland and the UK. So it's great to have Bertie on the webinar this evening. And he's going to be joined by his colleague Arthur Dunn from the farmyard design side of the business. And they're going to give us an insight into the current market interest in milking systems. So I'm really looking forward to that. After Bertie and Arthur are finished, we're going to move swiftly on to William Conlon from Lely Kilkenny. William is a senior member of our yard design team, a very experienced man designing and planning robotic milking systems. Huge experience of both indoor and grazing. And he's going to look at the design and costs implications of large-scale robotic milking systems. So as I said, William have experience of large indoor systems and large grazing farms as well. So that will give us a lot of food for thought. And last but not least, we're going to have Jordan Malloy. And Jordan has 10 years experience in farm automation and robotic milking. And she's going to focus on the overall running costs of a robotic milking system. So she would have analysed figures from a lot of customers over the years, and she's going to present her findings for all of us to see and ask questions on. Incidentally, if you have any questions throughout the webinar, if you use the chat facility, we're going to have a live Q&A at the end. We're going to have all the speakers, and we're also going to be joined by a farmer as well, Daithí Maher. So if any questions crop up over the course of the webinar, put them in the chat facility, and we'll do our best at the end to answer the questions. So without further ado, we'll move straight on to Bertie.
Yeah, Niall, good evening, and thanks for inviting us here today or tonight for the webinar. Okay, so I suppose you've asked us to focus maybe on the inquiries we have for milking facilities. I guess if I roll back a bit, it probably really took off for us in 2014, 2015, inquiries for farmers who were looking maybe to upgrade or develop new milking parlours. So we would have had a very big run of inquiries from that 14 period up to, I suppose, realistically 2022. I suppose everyone remembers then COVID hit, the war in Ukraine broke out. So what we found after then in 2023 and 2024, I'd say inquiries basically collapsed for that period. So that was due to, I suppose, poor milk price. There was a lot of poor sentiment out there in the marketplace. There was a lot of negativity, I suppose, towards farming. Towards the back end, I guess, of 2024, then maybe August, September last year, milk price started rising. Maybe the pressure on farmers or the sentiment improved, you know, just in terms of the public perception of farming. So I suppose from there on, we saw an improvement in inquiries. I guess it really ramped up then in January. So the inquiry levels, you know, they probably started to match that period there before 2022 again. So I suppose, look, the level of inquiries is very strong at the moment. A lot of that is backed, I suppose, by the good milk price. Milking parlours and, you know, be it herringbones, rotaries, or robot systems, they would have probably dominated our inquiries, but I suppose it's no, I have to probably say it is slurry storage is where the main inquiry levels are at. And that probably does dominate our inquiries in terms of a breakdown of them. So if we're to focus on, say, back onto milking systems, what are we seeing people investing in? You're going to talk tonight about, William's going to talk about investments into rotary, William tonight is going to talk about investment in robotic systems. What are we seeing people spend, I suppose, if they're going down the herringbone route? Again, there's a huge range, I suppose, we see in terms of what people are investing. And a lot of that is down to the level of automation they decide to adopt day one. So we're seeing a range for both the hardware, which is the machine, and maybe the investment in the shed and the concrete. it's anywhere from 250 to 500,000. We've obviously seen a lot of inflation in recent years with projects, be it in the agricultural world or the commercial world, so that there has been significant creep up in prices. I would say there's a lot of very good value for people who spent in that 215 to that 220 period. There was a lot of very good value got for people who did make the jump then.
Question for you, Bertie. How much, a percentage-wise, do you think making equipment has changed since back then? Overall, the market, you'd have a good insight into the whole market.
Price or the type of automation?
Well, I suppose interesting the price, and are people buying higher spec systems than what they would have a number of years ago?
I would say they are, Niall, and look, I think a lot of people would have put in, when it comes to herringbones, they would have put in cluster removers, but there might have been milk meters. There may not have been a drafting gate. I think that's changing, where people are definitely putting in say, your cluster removers, maybe some sort of a milk or milk yield recorder, be it an indicator or a full meter, and they're definitely putting in the drafting systems. A lot of that is labour related. You're probably getting a better deal too if you're buying the whole lot day one. You know, historically, maybe when it came to rotary, there was maybe, you know, if you were putting in a 50-unit rotary, there was maybe a big consequence to putting in a lot of automation onto that because you were paying per unit. So maybe there wasn't historically, but again, I'm seeing a change in that, where even grass-based systems, maybe people are putting on milk meters to know what cows are performing, what ones aren't. So there has been a change, I think, in the mindset of people there when they are investing, especially if it's an owner-operated farm, it's their main family farm, they're operating the farm themselves, they're prepared to invest a bit more to make their own life a bit easier. Typical spends in rotaries, again, look, it's probably at the lower end. It might have been more achievable, say 4 or 5 years ago, but look, we have seen jobs where it's done for maybe 550,000 for a 50-unit parlour. Look, a farmer in this case may have had, he might have been working off an existing dairy, had his same electric connection, had the same milk tank, different things like that. But at the other upper end then, where everything has been built from new, and a fair level of automation going into the rotaries, we're seeing a spend of about 1.2 million. So it's a significant investment, but it's typically on the larger scale farms, milking 250 plus, owner operator and maybe the farmer himself in the parlour themselves milking the cows. So there is a bit of a jump, obviously, as you can see there, from a herringbone up to a rotary. The rotary is filling a bigger footprint. So you know, there's differences in the project, or you know, there's more involved obviously in the rotary project. But, and I would say, look, to be fair, at the moment, the majority of our inquiries would probably start with herringbones when it comes to milking systems, then robotics, then rotary parlours. We've had maybe 2 to 3 live projects this year on rotaries. There was a lot more in the UK where we're offering a similar service in the UK through David Walton, who works with us, but there was more activity in the UK on rotaries at the moment.
Where do you think that the changeover point is from going from a herringbone to a rotary?
It very much depends on the individual, I would say, Niall, to be fair, as well as part of it. But you know, it's that 250, that 200, 250 with people who are milking on a 200 cow herd, they're in a rotary, but they're in it themselves. I find it's like, you know, if a farmer's doing the machinery work on the farm himself and he likes it, he'll have a good tractor. He'll have a €150,000 tractor or €200,000 tractor nowadays. But again, it's similar. If someone milks cows, likes milking cows, we have seen them invest in heavily enough in a rotary. It's something they enjoy milking, but it's that 200, 250 plus, realistically, in the main. So timeline to construction, it's obviously relevant in your robotic milking and how you approach it. You asked me maybe just give a small bit of an insight into that from where we see it. We see herringbone projects, I suppose, taking 3 to 9 months to build, where one has planning. Rotary projects are a different animal to build. It can be a 6 to 18-month project, maybe 24 months. What factors affect the pace of completion? There are many. So a lot of it depends on the builder. You know, what scale is the builder at? What size of a team they have, what experience they have, especially with rotaries. Another thing I would see, especially with larger projects, who is the project manager on the farm? In fairness to farmers, you know, they're multi-talented. They can do accounts. They can look after livestock. They can deal with the banks. So there's nothing they're afraid to take on. But I would say in the larger projects, the role of a project manager, which can fall on the farmer's shoulders, is something that it's a large responsibility. So especially if you have maybe someone supplying the shed, someone doing the concrete, and you obviously have a company supplying the milking machine, there is a lot to pull together.
And is it just that decision making, Bertie, that you see being the challenge there?
It is time to make decisions, and making decisions in a timely manner, William. You know, you've an electrician involved, you'll have a plumber involved, you've a lot of different things going on, and there's a hell of a lot of work goes on underneath the floor of the concrete, getting your foundations right, your services, your ducts. There's a lot to be done, and invariably a lot of farmers won't have done it before. So, and it's not that they do a bad job, but it just takes time to get their head around, and it can just add a lot, get all the disciplines together and get them all working in motion together.
What can go wrong, Bertie? I'm just thinking, obviously a busy farmer and the project could be €1,000,000 as you alluded to earlier on. What can go wrong when you have the farmer managing the project himself?
I would say just time gets lost. Time gets lost where you might be waiting 3 weeks for a plumber, or you miss a deadline for the plumber to run his pipes and electrics. It is just maybe having the sequence of various trades coming on site wrong. Look, a huge thing can go wrong in a farm development as well is having levels wrong. You know, if you're not in control of the levels, no, look, obviously the builder will hopefully have a lot of that, but some builders will only take it from a certain point and just fill to go in or whatever. But if your levels are wrong and you're introducing a lot of fill into a site, it can cost an absolute fortune if you have trucks coming in your drive. So that's one thing. But I would say it's mainly on the time side, Niall, where things go wrong. When the project gets done, it gets built. There's nothing wrong that way, but it is where a project that maybe should have taken 9 months takes 18 months.
Would that have implications then for costs and budgets? Do these projects typically come in on budget or over budget in your experience?
I would say a lot of them come over budget. Maybe look, there's a difference. You look in maybe smaller projects, you obviously see farmers maybe trying to fund that out of cash flow. That can lead to trouble too. If your project goes from 6 to 12, 14 months, and you hit you've come from a good year where you're funding it through cash flow, and you come into a bad year, you can just run into a bit of trouble that way. But inflation obviously can change very quickly. We've seen that over the last 2 or 3 years, so it's been ahead of that way. It's been ahead that way. It's important. But look, these are all big projects to build, and it's not to take for granted. I suppose the key is that you keep your business running well. If you're putting your cows in calf or you're calving or whatever, there's a lot to manage. You just don't want to drop the ball there. It doesn't happen very often, but we do see project managers employed from the outside. You might spend 15 to 20,000 on it, and people will say it's a lot of money, but you could have a lot of peace of mind for that too, where maybe you only have to deal with the project for 20 minutes a day as opposed to being available 8 to 10 hours a day. So it's something to consider, and it's just a factor we see that can go wrong with farms. We touched on this already. What level of automations are farmers adopting? I would say in general it's increasing. In a herringbone, look, 10 years ago, cluster removers would have been seen as, well, look, they're a given now that they're on herringbones. Auto drafting as well, we've seen a lot of that, obviously, with cow collars and doing heat detection with that. And also auto washes as well. So look, auto drafts, cup removers, auto wash, and some level of milk recording as well, we're probably seeing. And as I said, from a basic level at the milk indicator level up to a full meter. But again, across all systems, I suppose we're seeing that. And a lot of this is obviously labour related, which we'll touch on later, but a lot of it is labour related. Rotaries, I would say herringbones traditionally attracted probably more automation in terms of making meters, different things like that. So what I would say there's a difference in the UK is that there's typically a higher propensity to use more levels of automation over there. There always was, I suppose, even with tractors or cars coming in from the UK, they usually had a higher level of spec. Maybe the mindset is different over there, where they will use higher levels of spec on their equipment. A lot of that is labour related as well. What we're seeing as well, Niall, over there, maybe rotary projects in the UK where they're built maybe 10, 15 years. Maybe somebody started out making 500 cows, they're gone to 1,000. What we're seeing is that they're putting in maybe a robot to do the teat preparation, and they're also putting in a robot to do the teat spray. And I suppose the key to that is having the space that cups on and cups off to do that. But there are companies, I suppose, specialising now in retrofit of automation on that. We're also seeing maybe on new projects, more so in the UK as well, is high levels of investment going on to maybe even semi-automated rotaries, where you have one person in a rotary environment where there was probably 3 to 4 previously. They're spending maybe 20, 30, 40,000 a unit, depending on that level of automation, but those systems are coming as well. And the adoption of automation, again, a lot of it linked to scarce availability of skilled labour.
I'm guessing that's a trend you see coming this side of the water as well, in terms of robotic arms for teat spraying and that kind of automation added onto rotaries.
I think so, William. I think you'll see that. I think a lot of the trends in Ireland, like from look, just we're involved in precision ag as well, and what happens in the UK typically follows here. I think what happens in the UK usually follows here, and I think that you will see where rotaries were installed maybe 10 years ago. Maybe if it's a 2-person scenario or whatever, there will be automation. More likely than robotic teat spray, probably is first. But again, I think the key thing for that is that there is enough space. Some buildings maybe were built a bit too tight, trying to keep costs down. But the key to automation or these robots is having space available to install them. So that's something I think it's more common in the UK. You'll see it come here. So the typical constraints, I suppose, then to look at when investing in one's milking system, I suppose, look, why are people maybe ringing us or ringing you? A lot of it is related to labour. Milking sometimes can be a difficult job on some farms. Maybe milking long hours, maybe in poor dark environments. It's something that has to be done, but sometimes it's a lot of the reason for people giving up milk production. So I suppose when they're ringing us or ringing Arthur there or the rest of our team, look, they're either looking at maybe extending their herringbone, building a new herringbone, maybe considering robots or considering a rotary. So we find a lot of it. Say if someone is building a rotary, look, there's a long payback required for that. It's a 20 to 30-year project. Not saying the rest of them are, but it is a big investment. So look, you need time on your side with a career or a succession plan. We're looking at other people then where maybe look, they're building a herringbone, it's going to be greenfield, or they're going to work within an existing site. Sometimes it's difficult to work within an existing site, something built in the 70s or the 80s. You may have part of a solution for a handling area, but usually the sizes are wrong. The widths of the buildings are wrong, they're dark, there's no light. So it works in some places, but I suppose, look, what we find with some people, maybe they're trying to extend the herringbone, they're just trying to limit the level of investment that's needed. They don't want to maybe spend 200, 300,000, but they want to stay in milk production. We're equally seeing then people with robots, as you're seeing every day. Maybe they're considering that physically they're maybe not able to for the milking process. They want to bring in some level of automation. They want to stay in milk production, and the robotic route maybe is something that they're considering then as well. And maybe at the more extreme end, then we are seeing some people who are saying, look, I'm not investing in anything. I go once a day. And people look successfully can do that as well. It's not for everybody, but there are people who say, look, I'm not spending anything in my milking parlour. I'll maybe instead of milking for 1.5 hours, I'll spend 2 hours in the parlour, but I'll do it just once a day. That's an option as well. But I think all these key decisions are just maybe a wider view of it. I think, you know, we've had a really good year this year in milk production. Obviously, we've had 2 very difficult years in 23 and 24. But anyone that's ringing us in a way, I suppose, subconsciously, they're just trying to stay in milk production, whether they want to expand or they want to maintain an income. They're just trying to improve their milking facilities. I always say to people, it's very hard to find an alternative business to milk production. You get a check monthly. You know, to generate similar income from, say, a cafe or a shop or whatever, it's not easy to generate that level of income in an alternative business nowadays. So I think it's obviously really worthwhile people's time to try and invest time so that they can stay in milk production for as long as possible. It's not possible for everybody for health reasons or whatever, but you know, if it's some level of automation, it's maybe a robot or it's whatever. But I'd always be very strong with people if they can stay in milk production where possible, because you know, the day those cows leave, it's a massive difference not having that monthly check coming in the door, you know. So I suppose we all have a role to play maybe in helping and shape those decisions, but it's hard to beat as a dairy business to generate income for a family. So that's kind of what we're seeing, Niall, out there. You know, so again, look, I suppose milking systems is one part of slurry storage is probably the bigger thing maybe that's going to possibly push people out if they're not prepared to make the investment to keep their farms compliant. It was maybe milking systems before, but it's probably slurry storage and the whole investment required around that. That's where the main pressure, I guess, is on people currently, and that's probably why we have the most inquiries on that front.
Fascinating insight, Bertie. Appreciate it. Just a question for you. You mentioned the fully automated rotaries. I don't know if you've any experience. You were saying maybe 20, 30,000 per unit. I'd imagine that'd be outside, you know, the budget of the majority of commercial dairy farmers, that level of expense.
Yeah, I would say it is. And again, it's never say never for Ireland, but it's really in the UK environment where maybe people are making 3 times a day, Niall. You know, with Brexit and, you know, and then again, restrictions tightening on getting people in from abroad. Some farms are finding it very difficult to get people. So it is coming in the UK, and it probably is justifiable where you're milking a large number of cows 3 times a day, maybe the machine running 20 hours a day. It's not for Ireland, that system, or whatever, just the way our whole dairy industry is set up, but it is relevant in the UK.
Thanks very much, Bertie. I think we're going to move on to Arthur now. So hello, Arthur Dunn. You're going to give us a little bit of an insight from your role and what you do.
Yeah, perfect. Thanks, Niall. So I suppose I'll be based with the farmyard design department with the Grasstec. So meeting farmers from the initial design processes, from the survey design, taking it through to planning. So I suppose look, what I talk today is a bit more about the planning side of things, what we are seeing. So typical timeline for planning application. So 8 weeks from when you initially submit your planning, the local authority must make a decision. Within that 8 weeks, or the first 5 weeks after the plan is submitted, submissions or we'll say appeals or people are rejecting your planning, they have to be made within 5 weeks of the council receiving the application. From that time then, after the 8 weeks, the final grant is, or the, sorry, I'm tripping on myself here. After the 8 weeks, the council then have a 4 to 6 week cooling off period. This is mandatory. So anyone who's made a submission within the first 5 weeks, they can then appeal to An Bord Pleanála. And after that, then after those 4 to 6 weeks, the planning is either fully granted, assuming there's no submissions at that stage. Once the full planning permission is granted, you have to give a compliance or commencement notice to your local authority. So this is done at least 2 weeks before you start building, not more than 4 weeks before the commencement of the work. So everything going well, and in an ideal world, the total time it would take would be 14 to 16 weeks from initially submitting your plan to when you could actually start doing the work.
And then, Arthur, if you're to say, from when you first meet a farmer until that, and 14 weeks time is over, are you talking pretty much 20 weeks nearly, like in terms of from first meeting until final plan nearly approved and ready to go at building work?
It wouldn't go that quick even, generally, William. So I would say from initially calling out, we would do a detailed survey. So we'd go out, do the survey, do the design, and it would be a lot over and back, with the farmer. So like the idea that you get it done in 20 weeks would be a bit tight. You'll be talking closer 6 to 9 months really before everything is agreed, it's in for the planning, and you'll get ready to go on.
Yeah. And I suppose it's important to note then as well for, you mentioned on the slurry storage side of things that if someone is looking at making a grant on slurry storage, they have to have planning permission fully approved before they can make that grant. So they need to, I suppose, factor that into their time frame as well.
Exactly. So that could take 6 months to get the planning approved. Then you have to go for a TEMS application. It wouldn't be long, being a year passing on before the builder gets around to getting to your yard.
Yeah.
A quick question, Arthur. Do most people get planning permission? Like what sort of percentage of people don't? Just off the top of your head, if you know.
I couldn't say, but you would see maybe 1 in 5, 1 in 6 yards you go into and you're doing a plan application. There might be some retention to be got on it. But typically anyone applying for a grant needs full plan permission, and everything in the yard has retention at that stage,
Well, would it be fair to say the majority of people do get approval?
Yeah, no, the majority would get approval. Yeah, that would be fair to say. Yeah. So I suppose what are the common problems that can affect plan applications? So I suppose proposed farmyard developments and an underpass in the one plan application. So just say you're going down building a shed, a few cubicles, and putting in a robot, and you're putting in an underpass at the same time. We find that a lot of councils come back with different requirements. So you might need a TAR report, which is technical acceptance report. You might need, we say, an archaeological report, NIS, these different reports, and it varies from council to council. So they do take a while to get through planning underpasses. So we'd recommend to farmers, if there was a shed in the farmyard going ahead or a tank in the farmyard going ahead, as well as an underpass, to actually split them into 2 separate applications. So if the underpass drags on, you can still get your full plan permission in the farmyard and get cracking at that project.
And would planning for an underpass ever delay the even if 2 separate applications went in, would the underpass application delay the shed application, or would it have any impact on it from your experience?
Well, typically we put in the shed one first. That'd be the normal route we go, get that over the line, and then we go for the planning.
For the underpass, okay.
Yeah, for the underpass, yeah. So another issue we see is compliance with storage requirements. So a lot of farmers wouldn't have separate soil water storage or storage for their parlour washings. So current legislation, you need 31-day storage for your soil water if you're storing it separately. If it's going into the same tank as slurry, then it's 16 weeks, 18 weeks, depending if there's only A, B, or C. So the difference is huge in that respect. So person in zone B would need 4 times more soil water storage if there's been stored with slurry than if it was just a separate soil water tank. So when it comes to, let's say, doing the figures, seeing how compliant farmers are, that's just a stumbling block for a lot of farmers we're finding. Another one is effluent collection. So from straw bedded sheds, or if you have a dung shed, where is that runoff going? The councils, when they come out, they're finding that in places too. It's been an issue. I suppose another one is the location of the well. So most farms, the water supply is from a well. A new tank would have to be 60 meters, at least 60 meters from a well. And in some cases, I suppose as the farmyard has expanded, it's coming closer and closer to the well. You can get an exemption to have it between, or let's say down to 30 meters, between 30 and 60 meters, but you need a hydrogeological survey, and that's another expense then as well to do that. So what we find can make the planning process more smoother. So I suppose get a head start with a consultant. So I suppose engage with someone, for example, like Grasstec, people with experience in the design, get your design nailed down, know exactly what you want to do with it. I suppose have clear plans and justification for your build ready. So like that, have a proper survey done, have your plans on paper, build in times for delays, because inevitably there will be delays, whether it's, let's say, a delay, let's say, coming to an agreement with a design, a delay with a submission from someone in your planning application, an FI request, which may require you to get an NIS or some other report done. These things then can add weeks and sometimes months to a planning. Another thing, choose a planning agent who will follow through. So we'll find there sometimes with people coming to us, they might have got a planning agent who, someone might be local to them at home, might have a huge amount of experience. They might be more on the building side of things, going for plan applications, or house or dwelling or commercial side of things. So if a further request comes through from the council looking for, let's say, what way effluent is running in the yard, or land slurry spreadable area, things like that, they're not, I suppose, answering the council's request, or they're not engaging with the client, and then time runs out and not making deadlines. And sometimes people come to us and it's 9 months down the line and they're coming to us and start all over again. And then another knock on that is a year down the line, has materials, has labour gone higher again. I suppose the final thing that I'd say is don't panic over objections, particularly from these so-called serial objectors. We're finding they're just copy and pasting most of their submissions. It's a lot of legal jargon, which is essentially just telling the council to do their job, which is saying that this person is in an area that requires a NIS, with a Natura impact statement. It's something the council would have flagged themselves anyway if it was required. So I wouldn't panic if I saw it. If things are addressed at, let's say, further information stage, it's very slim the chance that he's going any further time on both and all.
It's fair to say the objections don't generally stop projects. They might add a little bit of time onto it, depending on how quick you get back with further information. But picking up from what you're saying, they don't really stop a whole lot of projects, do they?
No, they wouldn't. No, typically no. Once it's addressed, once the council come back to you with your further information request, and once that's all addressed, there's never, very rarely there'll be an issue, a very slim chance that there'll be an issue that will go any further.
Okay. Thanks very much, Arthur. It really does emphasize the importance of maybe hiring a consultant, someone experienced, people like Grasstec to help you maneuver through the process. So very insightful and a lot of very useful information. Thanks very much, and appreciate the questions coming in the text. Keep them coming, and we'll do our best at the end to answer most of the questions, or all of them if we can. So we might keep on motoring. So now I'm going to hand over to William Conlon from the Lely Kilkenny team. He's a senior yard designer. So William is going to give us an insight into design and costs of large-scale robotic milking systems. So over to you, William.
Right, thanks Bertie and Arthur. I'm just going to talk a little bit on the building requirements for large-scale robotic systems. So I'll keep it as brief as possible, but like that, if you have any questions, put them in the chat box and we can answer them afterwards. So generally for our 2 to 3 robot farms, we're looking at a head-to-head layout where robots are situated just off a slatted tank. For larger scale projects like the one on the right there, you're looking at a checkout system. So this allows you to get an awful lot more robots in a smaller footprint. So we see there on the right, you have 4 robots in a fairly compact area. You'd arguably fit 4 robots in a checkout system in the same place that you would fit 2 robots in a head-to-head system. So it is just a key consideration when I'm out on farm. You're looking at seeing where the scope is for expansion, what kind of numbers of cows and robots you're looking at initially. But for the purpose of this presentation, I suppose it's more so checkout systems we're looking at, because we're looking at large scale robotic milking systems. So anywhere from, 3 up to 7, 8 robots for a grazing system. Again, this is your typical checkout layout. So you will see all cows into the robots from one side, which will be this near area, and then they exit through the robots out onto another small slatted area. So the one thing with a checkout system is there is more slatted areas required than if it is a head-to-head area, and that's just something to be conscious of. We'll look at exactly what sizing and space is needed for a checkout system a bit later on. So again, all your cows enter from the one side, enter into the robots and head back out. Generally, you'll have one robot room in a checkout system can do 2 robots. So you'll see robot 2 and 3 there are working off the one robot room. And robot 4 could potentially, that room that has robot 4 could potentially house robot 5 as well. So generally you're setting it up that, 2 robots can work off the one robot room in a checkout system. Again, here, this is just a job, a 4 robot job that was actually fitted. So you'll see 2 robots facing each other. Cows are standing in beside each other when they're milking. I suppose the benefit with a checkout system as well is there's very little walls actually needed around the robots in a checkout layout. So you're probably looking at probably a little over 25 foot of walls for 2 robots, for a robot room to house 2 robots. So the building work above ground level for a checkout system is minimal enough, which can be another benefit. A lot of the jobs we'll be looking at doing, when it comes to a checkout system, all right, there might still be some greenfield builds, but an awful lot of builds, you're kind of utilizing the existing yard as best you can. This is a job done in Carlow, 4 robots fitted, but there was actually space left for a 5th robot. So this picture was taken before the robots were started up. So cows are entering and exiting through the area, through the existing collecting yard to get to the parlour before the robot started up. The robot shed, the 4 robot shed itself is about 45 foot by 60 foot. And like I said, there is space for that 5th robot in there as well. So not a big build, not a complex shed, a very simple shed and I suppose concrete work around the robot rooms for a potential 5 robot setup. What you will see here is, when you get into those bigger numbers, space around robots is important. So you'll see the 2 red boxes on the lower side of that screen. They're the 2 drafting gates for cows to go out to grass. So there's the option here to be A, B, C grazing, and also an option to send cows into a shed for a buffer. Additionally, you have another option then to separate cows out either to a cubicle area or to a local paddock. So that can be very useful. If you're dealing with 300-400 cows in an automated system, you need an efficient way of drafting those cows out and having them somewhere that you can handle them or bring them back in to be AI'd without having to try and chase cows. So the setup of the grazeways and the drafting areas on a large scale robot system where they're in checkout nearly takes as much work as trying to set up the robot area itself. So it's just something to be conscious of, and the space that's needed around the robots, both in front of the robots and around the drafting gates, very much depends on the number of cows you're looking at in the system. So that's something that I would be taking into consideration, along with working with the team in the farm advisory side, to make sure we have enough space for the number of cows you're potentially looking at milking. If we look at costs for these large scale robot projects, so there's a bit of variation depending on if it's into an existing shed or if it's a greenfield build. For a 4 robot project, with, I suppose, keeping investment in infrastructure to a minimum, maybe going into an existing shed, like you will see David and Daithí Maher did later on, you're looking at the lower end there, maybe around 550,000 plus VAT for probably up to a 300 cow herd. Now that could be up on 650, 700,000 if it is a greenfield build for 4 robots. The thing I would see is that the footprint of the build for 4 or 5 robots doesn't change dramatically. To leave the space for that extra robot in any project is only maybe an extra 12, 15 foot, just to give yourself that scope. But you probably are looking at a project of 550 to 800,000 for a 3 to 350 cow herd. Now, if we compare that, I suppose, to the parlour option, I know a figure that the likes of Teagasc would have used over the years of between 16 and 18,000 a unit for a parlour, would put 24 unit parlours around the 400,000 mark or a little bit above it. So I suppose it is trying to compare like with like. If you're looking at rotary projects for 300 cow herd, I think robots become very cost effective option. If we look in the larger herd again, then 400 to 500 cow herds, so we're talking 6 to 7 robots in a checkout system. The total project there, depending on the building work needed, you're looking from 850 to probably 1.1 million. And again, that 1.1 million is probably on the moving towards the greenfield build side of it. the biggest cost in any of these projects for large scale checkout systems is probably the slatted tanks that you will have before and after robots. Now there are different options with that too, you know, in terms of different systems that can be used maybe to avoid having to put tanks before robots or after robots, but that's just something we'd have to, I suppose, look at when we're on the farm. There is a good potential as well to retrofit robots into existing sheds. You know, you have the likes of Dave and Maher, who's you look at later, into an existing shed, a 4-robot setup, so we didn't have to build any shed. And that is, I suppose, common enough in my role that you would see a lot of larger scale projects going into existing sheds. But those prices are, I don't think they're a million miles away from what you would be looking at spending for, you know, large scale system. So just a little bit, I suppose, on the building work that's needed. So this was a 4 to 5 robot plan that I done recently. We have a bit of an existing tank in front of the robots, but if we didn't have that, you're nearly looking at a 60-foot tank before cows go into the robot. At the lower side of the screen, another 60-foot tank, probably a bit not as wide when cows come out of the robots, and then a double tank down on the right-hand side for the grazeway drafting gates to sit on. Like the shed itself there is 18.5 meters by 17 meters. So, you know, 60 foot by 50 foot maybe. It's not a massive structure to actually fit, you know, potentially 5 robots into. And we still have good separation options. We still have good space around the robots for cows to move. Again, I suppose what you're probably saving in a project like this, you are saving on your shed, both in terms of size and complexity, I suppose. Over to the right-hand side, it's a double 14-foot 6-slat tank that's running down along the right-hand side there. Again, gives good space for cows to move around when they're coming in from grass, get access into the robot's milk and get out again. Important to note, I suppose, that all the jobs that we would do, you are looking at free cow traffic. So you're given as much space for cows to get in, shy cow or to get in from, or a heifer to get in from grazing, get into the robots without a bottleneck happening. And that is the one big thing I would say that becomes even more important on large scale projects, is avoiding bottlenecks. Because a bottleneck on a robot system, when you're talking 300 to 500 cows, can back up the system very, very quickly. So you're trying to create as little places where a cow can cause an issue or cause a bottleneck as possible. So look, I suppose we've had good experience over the years with larger scale projects and seeing what does work well and what needed to be changed. So we're trying to bring that forward in the plans we do. Because, you know, you are trying to get cows to visit robots probably 2.5 times a day on a grazing system. So there's an awful lot of movement around the yard, middle of the night, middle of the day, you know, 24 hours when you're not around the place. But that just gives you a good snapshot of a fairly compact build, I would think, for 5 robots, and keeps the footprint of the job fairly small. If we looked in at a larger project, you're looking for a 7 to 8 robot project. So the tank now in front of the robots, we're in the 4 to 5 robot project. You were looking for a tank of about 60 foot long. You need about 100 foot long of a tank to service 7 to 8 robots here. Again, before you need that tank before cows enter in the robots, and potentially when cows exit the robot. Now, there's other options to clean that area too. I've seen robotic scrapers used, or the likes of flood wash systems or traditional scrapers potentially used as well. But that's all just something we'd have to look at when we're on the farm. Static tanks make the job easier to keep clean. Again, you see here now, because we've gone bigger numbers and the space has gone bigger, if we look out to the left-hand side where the grazeway gates are, you're looking at 3 14-foot 6-slats beside each other. So again, the whole project has just gone a little bit bigger. That's about a 20-meter tank, so maybe 70-foot tank in length for up to 500 cow herd there. So you've very good space in that plan, both for cows enter into robots and when cows exit out of a robot. You would see in some, I suppose, 1, 2, 3, up to 4 robot jobs where cows that exit the robots and they might be into a narrow race. I suppose when you start going 4 robots plus, you ideally like to exit out into a wider area, again, just purely based on the number of cows you're dealing with. But again, every setup is different. We don't like cows exiting out of the robots. You see here when they exit out of the robots into that area, they don't go through a drafting gate when when they go out through the robots and go left, they go out through a footpath or they go out through one-way gates. So again, there's no fixed barrier in their way, which is important, you know, in terms of preventing those backlogs or preventing bottlenecks. So before cows enter into the robot there, you have a 16'6" slat, just over 100 foot long, but that's just kind of what fits in with this project. But a 100-foot tank would suffice. And then when cows exit the robot there, we're looking at a 14'6" slat. Again, about 100 foot long is what you'd need for the 7-8 robots, a little bit longer here. And then, you know, like we said, the 3 70-foot long tanks out on the left-hand side. Most of your building work here again is all tanks, or it's, you know, there's very little. Once you get above ground level, the robot rooms is very, very minimal concrete work needed for them. It's just the slat of tanks that is the big investment outside of the robots here. So that, you know, that goes a long way to going from your 800,000 to 1.1 million. A lot of that just depends on how much of the existing facilities and tanks we can leverage, or how much have to be built new. You probably are looking at the best part of 150 to 200,000 of slatted tanks for a job like what we're looking at there in front of us. One of the big things that we would see as being a big help on these larger scale projects is the project coordinator. So my role is in the yard design. When I have the yard design done, I hand the project over to a project coordinator. They're responsible for making sure the project keeps on schedule, liaising with the different tradespeople to make sure that everyone comes in when they're meant to come in on the project, make sure things are done right the first time, and keeps drawings up to date. And I know it's something that Bertie would have touched on earlier in terms of having that kind of project management, project coordination side of things. We see it as being a massive help to keep projects on schedule. You know, we've turned around 4 robot projects in 3 months where you're leveraging the existing facilities and there's not a massive amount of building work to be done. Obviously, if there's slatted tanks and everything, it probably pushes the schedule to maybe 6 months. But it does give us a big capacity to turn around projects an awful lot quicker, having the project coordinators. It means the farmer isn't pulled away as much from the day-to-day running of a 400 or 500 cow herd, and that, I suppose, things don't suffer on the cow side because the farmer is focusing on the build. The project coordinator kind of takes some of that kind of pressure and that kind of decision making away from the farmer. Now, they're obviously still very much liaising with the farmer on everything, and they're still, you know, signing off on a lot, but we have the experience on that side of the business that we just make sure everything is, I suppose, done right the first time. That's just an example of a 4 robot head-to-head project that was done. So you can see that it just does take up an awful lot more space when you have robots in a head-to-head setup like that, as opposed to in a checkout layout. But that was for an indoor herd. 4 robots as part of a 6 robot project overall. Again, that's just an aerial view of the robots, the robot rooms as well. So these are some of the drawings that the project coordinator will be producing and updating as the project progresses, you know, in terms of levels, in terms of falls, in terms of duct layout, in terms of wall layout. One thing to note, when it comes to services underground, there's very little for a robotic system. So it's really just the blue lines you can see there on the left are the drainage from the robot rooms into the slat tanks. That's pretty much all the underground services that are ran for a robot system. Everything else that's been ran is overhead, so it makes it an awful lot easier to run services, which I suppose is just another point to note of the system. I'll just go back briefly, sorry, to this one. So you have the 4 hoppers above the robots, but you have 1 auger feeding the 4 hoppers. So that's just something to note as well, that the farmer is responsible for bringing feed, power and water to the robots. But you can see there that the auger system needed can be very, very simple. We like having bigger capacity augers above the robots. So if something does go wrong with either an auger or meal bin, or you forget to order meal, the hoppers can be filled up and it'll get you by for a day. So it's all about trying to set up the system to give a bit of breathing space in the system if something does go wrong. So that's it from my side, I suppose, in terms of the building costs and in terms of the layout for large scale projects. If anyone has any questions, feel free to ask and we'll answer them after. Thank you.
Okay, so thanks very much for Willie for going through that, and to Bertie and Arthur as well. So I'm just going to go through a little bit on the running costs of the robots. So the first thing I'm going to go through is just to mention an independent study that was carried out by DLG, on the Lely A5 robot. This was done a couple of years ago, and it was published in Profi magazine there back in 2022. But basically, you took 4 different scenarios, I suppose, depending on fast milking cows and slow milking cows and things like that. But we're just taking average, the scenario 3, which is the average kind of farm, which had a mixture of high milking cows and slow milking cows. So these are the costings that they came up with. So you have electricity, water, persic acid, which is put onto the brushes in between cows to disinfect. You have astri-sid and astri-lin, which is your alkaline and acid, and then you have your teak dip. So it's coming in around 15 to 16 euro per robot per day. So that's based on Profi magazine DLG independent study. And so then what I did over the last couple of months is I just asked some of our larger robot farms just to actually tot up their costings from 2024, and we divided up to a per robot basis. So I asked 4 farms and they got me the data. I should note that out of these 4 farms, they're ranging from 4 to 7 robots, but they are averaging up and going 9 years. So there is about a 60-40 split between A4s and A5s within that makeup. So just to note that, because A4s do have a slightly higher running cost, because air usage would be slightly higher and water usage would be slightly higher. So just to note that. But the average per robot then, as we broke it down, just divided up, so we just averaged it out. So chemicals is 2,200. So chemicals include your alkaline acid, your teak dip, and the only difference then of the parlours and rotaries would be that you have a cost of persic acid, which is put onto your brushes, which disinfects the brushes in between the milkins, and you also have Astri-Cell, which is the cell count solution that's needed to mix in with your milk to actually give you a cell count reading of every cow every day. So that's your chemicals. Your consumables then is your liners and filters, and the only difference then again to your parlour and rotary is that you have brushes. So that's also included in that. Parts then is just anything that was outside of a service. So any part that was used either by a farmer or by a technician that was used outside of a service that you're paying for as well. So that comes in around 900 euro. Then the call outs. So on average over the 4 farms that I asked, 2 of them had 1 call out and the other 2 had 2 call outs. So basically the average is 1.5 call outs in the year total. However, I just left it as 1 total call out. It should be 0.25 of a call out per robot per year, but I just left it as 1, so to round up. So a call out plus the few parts that were used during the call out comes in at around 250. Your service charge then is 2,500 per robot per year. Horizon is the computer package software program that runs the robots. So that is 60 cent per lactating cow per month. So that's done on a monthly basis, and it's done on a milking cow only basis. So a spring calf system that's milking 60 cows per robot, that's 60 multiplied by 60 cent. And then towards the back end of the year, you might be only milking 20 cows per robot. So that's 20 cows multiplied by 60 cent. So on average, it's around 300 euro for the year. So your total per robot per year is around 6,500. We also then did get the data of how many kilowatts were used per robot per year. So roughly it came in around 17,000 kilowatts per robot per year. So in around 4,000. And one farm did supply me the fact that a quarter of his usage came from solar. So in the whole year, a quarter of the usage came from solar. So 4,000 kilowatts. So that's your farm running cost there. What I've done then is just gone through a bit on existing farmers and their performance, just to kind of set what some of our farmers are doing. So what we did was we took the data from anyone who started up in a parlour back even as far as 2015, took their data for their last full year in their in the parlour, and then compared to that of 2023 and 2024 figures. So they could be up and going 5, 6, 7 years, or they could be going 2 years. So the goals and expectations vary throughout this group. So what I mean by that is people had different reasons of getting into robots in the first place. The number one would have been labour, followed closely by flexibility, but there would have been other reasons to put in robots as well. So cow performance, people wanted to drive on cow performance, management, so maybe managing issues on farms as well as say cell count issues. And then there would have been personal health and cow health issues as well. So they wanted to manage them a bit better. So what we've done is we've totted up the farms that are linked to us. So we have 163 farms linked with our centre on ICBF. So this is ICBF data. So what it's showing is before the Parlour startup and then 2023 and 2024 figures. So as you can see there, before in the Parlour, they were doing 470 kilos of milk solids on average out of the 163 farms linked with us. So 470 kilos is quite high. So I think the average last year for Irish farms was in around 410 or 415 milk solids sold per cow. So it is quite high above the average. Anyway, so that would have been a range between 300 kilos milk solids up to 600 kilos milk solids. Then we compared it to that of 2023 and 2024. So they did 500 kilos milk solids in 2023, and then they went up to 508 in 2024. So that was an increase of 33 kilos of milk solids. They went up a couple of 100 litres in milk as well. Fat and protein, give or take, did stay the same. Protein back slightly, probably more so because 2023 and 2024 weren't the best grass years that we've had. And cell count had dropped 14%. So I thought it was interesting just to pull the fact that there's 163 odd farms there, and that's their results. So just to bring it back to labour then as well. So your 2 robot farm, so your average of 120 cows, they have 1 full-time person, aka the farmer themselves, plus some part-time help in the springtime. The 4 robot farms that I asked, that are averaging about 270 cows milked, they have 2 full-time staff, so usually the farmer himself, or herself, plus either the partner or the father or someone else. So that's 2 full-time staff, plus part-time staff then for the springtime. And then your larger farms of 5 to 8 robots do have that bit more, obviously full-time and part-time staff. So it equates, the way we taught it up, it equates to roughly 1 full-time labour unit for every 150 cows. So, and the last thing I'd just say, just to kind of summarise about large herds and robots. So we currently have 20 large farms milking with robots at the moment. So anything that's over 4 robots up to 8 robots milking cows. Our largest grazing farm has 6 robots milking about 430 cows at the moment. We do have a further 22 farms that have an average of 3 robots. So that's in around 180 to 200 cows. It's already been mentioned multiple times already throughout this webinar, but it's just important again to just say that cow flow and space is critical. It's critical in any robotic system, but it's obviously more important once you start going over your 250 and 300 cow herds. So important for free cow access, so the cows can actually visit the robots coming to and from the paddocks. And then, as William already would have mentioned, that it is so important for cows to be actually able to flow around robots and grazeway gates and drafting systems, so that the cows, there is no bottleneck. So that is one thing we're highly, I suppose, critical of when we're actually doing drawings and layouts and liaising with planners and FMS. So we have full-time yard planners doing that, and as Willie would have explained already, that then with project coordinators as well. So that's more so on the building side of things, but on the cow side of things, very important as well. So you could have robots milking cows, but if no cows come to your robots, then nothing is milked. So we do need the cows to come to and from the paddocks. So we have full-time farm management support advisors, and that is their sole job. So grassland management, feeding, milk settings are important on every farm. Every farm is different. So I suppose different settings and different ways of managing grass for 300 cows versus 70 cows is different. And just lastly then, so obviously we have people, they're doing cow movement side of things and cow and building side of things, but then in general then we have over 320, 330 customers. So we have them broken up into 8 different regions throughout Lely, Kilkenny and Lely Mullingar area. So if you go with robots, you would then be put into one of these regions, these groups, and they have people that are ranging anywhere from a couple of months with robotic milking up to 13 years. And it's a great place for people to actually share best practices as well as what to do and maybe what not to do, and just the differences in different systems and different ways of managing things like droughts and bits and pieces like that as well. So I'm going to finish it there. If you have any questions, please do ask them in the chat box, and then please stay tuned for the David and Daithí Maher testimonial as well. So thank you. So I'm here with David and Daithí Maher. What we're going to do is we're going to go through their background of when they were milking the parlour, a 22 unit parlour, and their transition to 4 robot milking system. So you might just give me a background of where you were a couple of years ago, cow numbers, what type of parlour you were in, and just the background.
So we were between 190 and 200 cows, 22 unit parlour, dumpline air feeders, automatic cluster removers. We needed to do something. Labour was becoming a bigger and bigger issue, and we were looking at either upgrading the parlour or changing to robots or rotary or something to save time. That was the big thing.
Okay. So you're milking about 190 to 200 cows. What kind of yields and solids were they doing?
So we're in around 7,000 litres, around 550, 560 kilos of milk solids. That hasn't changed much since the robots went in. We had an established herd. We wanted to try and keep that, and we thought this was the time to change if we were going to change at all.
When did you actually start looking at robots properly?
Spring. The spring of 23. We had kind of ongoing labour issues for maybe a year and a half, 2 years before that. We had part-timers, but we were always missing that full-time labour unit, and that was falling back on me constantly. And it was actually funny, we were at the plough match, and myself and my wife Stephanie and the kids, Steph had never seen the robot, so we just went in on the stand and we were talking to Michael O'Grady and didn't really think much of it, just had a general chat. But Dad had gone up the day after and was also talking to, I don't know who was this? Willie. It was Willie Conlon at the same time then. And we both said it when we came back afterwards that maybe we should look at it, and we had both spoken to him at different.
Okay.
So coming on from that, Michael came down, we looked. In the meantime, we actually managed to get somebody full-time, but it just didn't work out, basically. So the following spring, we contacted Michael, and we started looking strong at a couple of systems. Travelled a lot of the country that summer, spoke to a lot of people, and kind of took it from there. And we had our deal done on paper in August of 23, and we were up and running in November 23.
So I suppose coming to the decision of robots, you looked at other brands of robots, and you were also looking at parlour and rotary as well?
Yeah.
Yeah, we looked at 3 brands of robots, and we visited, I suppose, a dozen farms of the different brands. We initially looked at rotaries, and the external build, the delay that would be caused by planning permission, and trying to work it in because of different levels around the farmyard, trying to work a rotary in with the accommodation just didn't add up. And so we sort of we narrowed it down to robots, and then we started the process of what colour.
Mm-hmm.
When we were looking at the parlour, we were between 2 tanks, so extending the parlour wasn't an option. So we looked at maybe going to a feed to yield system so anybody could milk, because our herd varies obviously, and we were trying to feed to yield manually by taping cows. So we thought maybe if we had gone a feed to yield system that might help. That was pretty costly, just to upgrade the parlour that was there. We looked at doubling the parlour, but power supply, we're on single phase electricity, so we would have had to look at getting 3 phase, and 3 phase is not close to us. And then how efficient is a doubled up parlour in that size? Like a 22 unit is efficient for 1 person, a good person to run on their own, but a lot of the time you need 2 people, or people want a second person there, but the second person is kind of wasted in such. So look, yeah, it was the manpower, back to time, back to most efficient ways forward. And after going visiting the robotic farms and seeing how how the other half were living, I suppose, is one way of putting it. We thought that this might be the way for us. Like, we didn't think that the cows would adjust. We expected more problems than what we got, and we didn't.
Yeah, even at startup, you expected a good, because 190, 200 cows on 3 robots
Yeah.
at that yield of doing, what, 32, 33, 34 litres a peak.
Yeah. Oh, it was completely on the edge, and it was yourself that brought it up that milk speed was going to be our deciding issue. But we stuck with the 3 because we were convinced that when we started, we were going to lose 10-15% of the herd, because like our cows go from first calvers to, I think the oldest one out there is a 12th lactation cow at the moment, and we started with I think it was 183, and 183 took to the robots. The following spring then, well, we thought strong, we had good milk speed, and we said maybe we might be able to push it to 200, but that would be an awful lot in our first year, and cow prices were on the floor. We had 60 heifers, we were going to have to sell 40 cows if we were going to bring in the 60 heifers. So we decided that maybe we should put in the 4th robot in January, and that's the route we went.
Yeah. So from there on then, you've been 4 robots and milking how many for last year?
Last year we averaged 225. This year we peaked at 237. At the moment we're back to 220, just through different issues. Cows getting on, cows getting old.
So going back to then the actual, so you made a decision in August.
Yep.
To go robotic from 2020 to August 2023.
Yeah.
So what happened between August and November, work-wise, to get ready?
Well, the paperwork was signed up, and I went out and started pulling cubicles off the walls. We had an idea of where they were going. There was just, I suppose, the positioning and the grazeways was just whether we were a few foot this way or a few foot that way. That was the only thing. So yeah, it was time sensitive, so we decided just to belt away. So we did wait until close to the end of August before we started jackhammering, and then we went hell for leather.
So the plan itself of the actual, because the footprint of the 4th robot even went in that time.
Yeah, so we built for the 4th robot. It was, at the time we were like, I'm better off put 3 cubicles there, and you were no, you should always, it's cheapest now, do it now. And then I was thinking, what was I going to do with this room? And I said, maybe I put a bag of lime in it and I parked the limer in there. Lo and behold, anyway, there was the 4th one went in.
So who would have actually gone through the plan, and I suppose the initial plans, and then you're finalising the plans, and then you're handing it over to...
Sure, Willie Conlon came down, and Willie talked us through where we were going to go and what options were there. There really only was the one option because we were retrofitting, and we were milking at the same time, so milking couldn't go undisturbed. A lot of gates tied up with twines around the places and cows held on roadways, but anyway, that was, and breakouts, and yeah, just it was heavy going there for a few weeks.
So, and then you would have had John Breslin kind of going, helping you throughout the build.
Yeah, so John used to come down, and kind of every few days he'd be down, and he'd kind of guess how long we'd be till the next part, and then he'd show up for that. But yeah, so once Willie had the drawings done, he handed over to John. John came down. I think John and Willie were there at one stage doing levels, and
once everything came together and everything was ready for install, or for install of robots and then commission. So how long did that take then between
the actual robots
and
stuff? I think the first week they done 4 days, long days, 4 men, and the second week they done 3 days with 2 men, and that was from the robots being taken from the shed and put in pipe work, bar work. I suppose one other thing to be added was our own electrician was there when that was going on too, and he done his bit, and sure, we kind of joined up the dots ourselves then, like with the bits of plumbing, and we had to put in a buffer vessel and things like that, and Yeah, I think that's about right, isn't it? 4
Yeah,
days, 4
yeah,
men,
yeah,
and then
about that, yeah, yeah.
And then start up the following.
and yeah, I think we finished on a Wednesday and we started up the following Tuesday.
What did actually need to go in for the robots to work?
So we had to put in 2 flow channels. One as a gathering area, so that was pretty wide. It was 110 feet long, 12 feet wide, and then an exit one that runs along the front, and that was about 4 feet wide and 90 feet long.
Okay, and that all led into a pre-existing
Tank.
tank. And that tank was what size?
14 by 40.
Okay, so and that's where your grazeway is.
That's where one of the grazeways is, and
Yeah.
the other one's on a tank beside
So
it.
that would have been needed. Had it not been there, that would have been needed.
that would have been needed. Yeah.
So you had the flow channels to put in, and then you had the concrete of the robot rooms.
Yeah.
And anything else then?
Sure, electrician. I suppose there's a few bits and pieces of miscellaneous items. Like we had to build an office and a compressor room. They weren't shuttered. They were an external contractor. Again, just man came in to lay blocks. Yeah, that's kind of like the concrete works came in at about 43k. The miscellaneous in the office came in around 10,000. Sorry, the robot rooms was included in that 43.
Okay, so that 43 was your
Yeah.
robot rooms,
Yeah, so
flow channels, and then you had your
and then 10,000 for the office and miscellaneous bits and pieces. Electrician was another 6,000. And then we're on to the big one, I suppose, the robots themselves.
yeah.
So the first 3 initially cost 380. And then the last one was 110.
Fair enough. So then the total, I suppose, adding up your robots, your electrical, miscellaneous, concrete,
Yeah,
and flow channels, then that came in at
565,000
okay for the total
for the
project,
total project.
plus the VAT.
Plus the VAT, yeah. Oh, plus the VAT.
Everything plus the VAT.
Yeah.
So that was the total project then. And had you priced beforehand in terms of parlour or rotary? Had you gone through any of the costings on that?
Yeah, we
looked at upgrading the parlour to full feed to yield and full management system, and basically what we'd have to do would have cost us the cost of a robot, that sort of money.
Just to upgrade the 22 unit.
And we'd still have the manpower problem and the lack of flexibility. If you get somebody with the Working Time Hours Act, you still have to work the weekends yourselves, and trying to rear we did it in our day, but trying to rear a family and have some sort of family life and milk cows. Yeah, you can't be a slave to it. Too many people are, in my opinion. So that really made the decision for us.
Okay. So even just looking at upgrading the parlour, so even if were you thinking of going greenfield or with a parlour or rotary, or did that even come into it?
We looked at greenfield with rotary, but we couldn't, as I said earlier on, we couldn't get it to work in. And when you looked at the costs, you still had the manpower problem.
We looked at trying to fit it into another shed that's across from the hole in the yard of calf shed, but it was just slightly too narrow. And even looked at putting in beams and just extending out where the circumference is the most in the rotary, but it wasn't going to work. Then we were going to have to go build a calf shed somewhere else. Where the yard is pretty well laid out, and to go build a rotary, like Dad was saying, if we either have to go, we had to go below the yard, so it means we go below the yard. Now in the wintertime you have the cows walking down slopes, and sure, with frost and ice and things like that, you don't want them walking down slopes in the icy time.
And then the other big one as regards to rotary was
back to the labour.
Power supply and labour.
Yeah, the power supply and the labour. Yeah.
So that it priced it out.
Yeah.
And you didn't get the same benefit. You couldn't go off to see a match of a Sunday evening. Somebody had to be there to operate the rotary at the end of the day. Life is for living. As I say, work to live, not live to work.
Grazeways out. So you have two grazeways because you're checkout and there's, you know. So from grazeways out to make ABC work outside, did you have to do much?
I concreted 40 pigtails into mineral buckets and a split roadway about 100 yards, and that's it so far.
Well, we did concrete.
Oh, well,
That's slow.
We concrete. Well, we didn't for the first year, but we had AstroTurf down on hardcore. Look, it was grand, but that close to the yard, and look, cows will congregate always close to a yard. It just got very messy very fast. So once the cows went dry and went in, we pulled it all out and we concreted maybe 20 feet either side of the grazeways and just the area around, and like already they don't even stand out there anymore. They just stay moving into the yard.
It's just a better surface.
It's just a better surface.
Yeah.
It's just a better surface.
So going through the comparison of the running costs now after a full year in robots versus, I suppose, the 2022 unit parlour that you had. So I might go through it because you've obviously haven't wrote down. So we'll start off with the main one, power usage.
Well, overall, the electricity consumption is about 50% more than it was with the parlour, but it's only about between 25 and 30% more in real cost, from the point of view that there's a larger proportion of the power being used at night rate than there was with the parlour. The other thing to be said is that the robots are heating their own water, so our gas usage has dropped to about 50% of what that was. On the overall operation, everything from scrapers to water boost and compressors and robots themselves and all the ancillaries, it uses basically a unit per cow per day, which is costing us about 30 cents per cow per day at the moment.
Okay, so that's total cost including
That's
the whole.
cost. That's everything from electric fence to pump and you name it.
Okay.
It's all on the 1 meter and easy enough to monitor.
Okay. And then I suppose from chemical usage then point of view.
Chemical. Well, the one thing that sorry, on the overall cost, the one thing that would have to be said that's compared to a variable speed motor parlour. I'd say we're using the same. Probably maybe even a little bit less than before we had variable speed motors on the 22 units.
So the power usage would have been.
Yeah, would have been far greater before we put in the variable speed on the parlour. So
and when did the variable speed went in 2020?
2021.
2021. Okay, so you had 2 years on the variable speed. Yeah. So if you compare it back to 2020, the robots would have been thereabouts with the ESB cost.
Yeah.
Okay, fair enough. So then chemical usage then, what roughly is that working out with? So you've
chemical usage is more or less the same, I'd say.
Yeah, a little bit less.
A little bit less, yeah.
Initially when we put in the 3 robots, it was about 25. There was about 20% less. So now with the 4th one gone in, it's nearly 95% of it. So, so like chemicals hasn't changed too much. Teeth dip basically in around the same, maybe saving a 10% less, but we were doing pre-spraying on cows as well. So
I suppose the service side of things, I know you're only in your, I suppose, 2nd year now per se, but you're on a service contract.
Yeah, we're on a service contract. Yeah. I suppose that was one of the things that kind of attracted us to Lely, was talking to farmers who had robots in 1 month or 10 years. They were paying the same for their service contract. You only pay for what you break, basically, and that was attractive. So yeah, they come in, they're doing their routine servicing. One of the lads usually rings me day before, maybe, or even maybe 2 days before, and say, I'm going to be there, is there any problem? I always make the joke, I'll tell the cows so that they're not in the way, but they just come in, they do their own thing, and if there's any issues, they'll ring you, or if you want to, they'll show you little things, because like, look, the life of these things is doing regular servicing and I suppose keeping things clean, keeping the lasers clean, keeping the cups clean, just keeping dirt out of the way is the key to them. and the lads will tell you, and they tell you if you weren't doing something right, they wouldn't be too long about pulling you up on it either. So
So I suppose just at the end of 2024 then, just cow production wise, where would you have ended up compared to, say, the year beforehand?
yeah, so at the end of 24, we will end up at 550 kilos of milk solids. 23, we had done 568, so we did drop back a bit.
But there were 60 heifers.
Yeah, there were 60 heifers. I suppose the main thing we found was our butterfat went up, our protein went up, SEC stayed much the same. When you have individual information on cows and you compare like this cow's yield to this cow's yield, and then you say, well, like this cow's only, you know, she done 6,000 litres, but here she only averaged 1.6, 1.7 milkings. The robot is very efficient. The amount of electricity you use to get the milk out, they're linked, and I think it's a great thing. But yeah, we've seen this year now, like cow movement was good last year. Now we did a bit of pushing in the spring to kind of get the herd mentality to break up. But like there was older cows there, 7 to 8 lactation, that dropped down when they started on the robot. Just thought it was generally older cows, yield gone down. This year they've flying back up again. Like there's one cow that's 9th lactation, and she was, I think she done 5,500 litres last year, and she's predicted on the robot to do 7,000 litres now this year.
Okay. So cow production wise, fat and protein percentages up last year, yield back a little bit, overall solids back about 18 kilos per cow, with 60 heifers in herd as opposed to 30.
Yeah.
So all in all, not a bad first year.
Oh God, no! I'd
So-
be delighted.
Going by this spring then, and prediction wise on the robots, and even going by your own figures, what are they kind of going to end up at this year?
So yield wise, we should be back to where we were in 23, but at the moment the solids do look like they're going to be up higher again. So look, I don't know, is the solids coming from the extra milkings? I have heard people talking about this, that they did find a rise in their solids, but the robot also forces you to be better at your grassland. Now we were good, probably grazing a little bit on the higher side, because we never wanted to run out of grass. You know, you didn't want to start the feeder in June. But now with the robot, we don't need to start the feeder. If we run out of grass, it could be a matter of putting in 1 bale, 2 bales.
What worries did you have that actually didn't come true? Or now that you're looking back over the...
I'm sure a lot of them you'd count now as urban myths. Like you'd hear the story of so-and-so put in the robot down there and the robots are gone, or the cows are all treated now, or he's out all hours of the night on the quad running around after cows.
The phone is ringing.
The phone never
stops.
stops. Yeah, the phone never stops. Yeah, look, we had all them worries. Didn't look. I suppose we expected a lot more hardship than what we got, and we got on well. Like we did get on well. Now, like, look, we didn't just put the robots in. Like we did. You put in the hard graft for the first few weeks. Even when they went to grass, it was still, you'd go out, you'd be watching cows, you'd be taking down numbers, and then you'd be checking on the phone, what time did she move? Is she moving fast enough? All them worries now are kind of gone. You just, look, you go get the cow that you need to get. Generally speaking, she is sick. That's why you're going to get her. Okay. But it's, well, most of the cows are moving themselves.
I think a big thing is knowing when to stop pushing cows in the beginning.
Yeah.
Don't give the cows the habit of needing a person to be there to get them into the robot. I think that, when I hear of people who are constantly pushing cows, I think that's the big mistake. You've got to let them find out, and it's amazing how well they adapt.
The solids, the solid indicator, like having 200 recordings versus 6, especially this time of the year. You go in, like you just pull up the cow's lactation. You have her predicted yield for the year. You have her fat and protein so far. You have your fat and protein every day on the dashboard interface. You have her milk speed. You have all these tools to breed the perfect cow. Like there's cows you would have been thinking that you were breeding from that were great, and then you go in and look at them and yeah, they had decent milk, but like then you realise the protein is on the floor. Like, so yeah, like that is helping with breeding decisions. Look, we haven't seen it yet, but we know we're breeding from our best now. So like yeah, in the next 3-4 years, I hope there should be a serious herd of cows. Like we've got good averages. Like we're at 3.7 protein as it is, but like I think we should be able to go a bit further even, and the robot will enhance that. Like,
How has the labour reduced since the robots have gone in?
one full-time labour unit less, and I suppose my hours have pulled back as well. Like I get a Sunday or I get a day in the week anyway, whereas I don't have to call upon someone to come in and do anything. I can do the wires, we can go off for the day. That's
Okay, so you're after, I suppose, one less labour unit. You have more flexibility and a bit more work-life balance, or less hours on farm. So which is kind of the main reasons why you...
the main reason. Like,
so it was labour driven, or it was...
like we looked at robots 10 years ago, but like I hadn't like any kids or anything like that. I'd work round the clock. You know, you just wanted to do it and didn't think they were for us. But like your perspective changes as you get older. Like now you have 4 kids and now we have to have them for hurling training. One night a week you have to go to a match. Your time's not your own anymore. And
But you liked milking?
I loved milking, yeah, I did. And it was probably the hardest thing not to be able to do. Like I was lost for the first few weeks, I'll be honest. I go out and you know what needed to be done, but you just didn't know where to start, because
milking added structure.
You'd be in the parlour and you'd be milking and you'd say, right, I'm going to do this now when I'm finished making, I'm going to do that, I'm going to do the other thing. Yeah, you were running around like a blue arse fly, but you were having your morning meeting with yourself, like. Which then you go out and the robots are milking away. Like now I know where my day goes and what I need to do, but still
It took a bit of time.
It took me longer, I'd say, than the cows. It did take me longer than the cows, and I'm still working on it. Like.
So thanks very much, lads, Daithí and David, for having us. We're after going through a fair bit there. So if anyone has any questions at the end of the webinar, make sure you write it in the Q&A box, and we'll be sure to answer them.
We won't keep this too long because I think people have heard a lot now over the last hour and a half. So we will go as quick as we can through a few questions. Jordan, I suppose there's a question for you on clarifying the power usage for the robots. And would it be much less on A5?
I actually haven't looked up totally on the larger herds. It was actually a combination of A4s and A5s. So I actually haven't done just A5s on their own farm yet, on their own. So I actually can't answer that. So I'm going to assume slightly less, but I actually don't know. I have to do
the figure Lely would say would be that energy would be about 20% less on an A5 than an A4, but so that's a figure to go off. Daithí, if you want to unmute yourself there.
Yeah, can you hear me?
Yeah, we can. There's just a question here for you on what is your target cow numbers for the farm and milk solids targets, I suppose, over the coming years.
Yeah, sure. We're kind of happy around the 220 to 240 mark. Milk solids, yeah, we're hoping to maybe push that up another 100 kilos over the next few years there, through both solids and milk, hopefully.
Okay. I don't know, is this a question for myself, or maybe Arthur and Bertie can chime in as well, but someone was looking for the cost of a greenfield project for 140 cows and 2 robots.
Take it away, William.
Well, I suppose the figures that I would look at, it's not exactly nice figures now, but figures the Chocks would be looking at if you were looking for slurry storage and the build, cubicles, everything like that for a large project, you're looking around 3,000 a cow. So 140 cubicles. Robots on top of that, you're probably looking north of 700,000 of a total investment. Now, it's probably important to note that with the grants that are there on slatted tanks and robots, you would get roughly about 130 to 140,000 back in grant, maybe more depending how if it's partnership or what kind of slatted tanks you put in. But you probably are looking at investment 650, 700,000, and then maybe 130, 140,000 back in grants, depending on what you go with. Question now, this one is for Bertie. Or Arthur, if someone hasn't gone for planning yet, would there be any chance of them getting a tank in on the 60% grant this year?
Arthur, do you want to take that?
Yeah, I don't know. Personally, I don't know. I don't think it will happen. There is a lot of talk that, you know, you will be able to put in tanks and be eligible for grants without having plan permission, but I don't think it's just as simple as digging a hole in the ground and tearing into it and looking for a grant. I'd say you will need at least to scale farmyard drawings. You might be some sort of planning exemption. It's still all open the area yet, like, so there's nothing
Yeah,
definite on that.
and I suppose even the fact that the rules haven't changed on it yet, you would struggle. Like it's unlikely the rules will change probably until the back end of the year if the planning exemption does come to fruition, and I'd be skeptical whether it will or not. That even to get a planning exemption and then get a grant approval through is still going to take a bit of time.
Yeah,
So I would
exactly,
say I would say it would be a struggle. Daithí, for yourself, when you're going out changing wires in the morning, would there be many cows left in the paddocks when you're going to change the fence?
No, generally not. There's generally, if there is anyone left, there's usually something wrong. They're lame or they're sick, and you'll find that out in time anyway. But yeah, no, generally speaking, no, not. Evening wires moved usually between 5 and 6, and they're generally all gone. The C wire in the mornings, same thing, kind of between 7 and 8. There's nobody there, and generally speaking, yeah, B is already emptied. So no, generally speaking, no, there's never anyone there.
That kind of leads into the next question of how long do you spend around the robots in the morning on a day like today, say, for example?
Right. So yeah, usually 20 minutes, half an hour. That's washing, cleaning around the passageways, changing the filters, just generally checking that everything is okay, checking your acids are in place and all. Maybe in the morning then to go do wires, another 20 minutes. That's 2 wires done, and then kind of 10 minutes in the evening to do 1 wire.
And then that kind of leads on to on a busy day when you're away from the farm, what would be your routine, or how long can you be away from the farm without having to go back?
For sure, I suppose the wires are the only thing you really need to be there for. During the harvest, like when we'd be very busy, I think one day I changed the wire at 6 in the morning, and it was 12:30 or 1 o'clock that night before I got back to change the other wires. Like that is the exception, all right. But yeah, generally speaking, you would get away with that. I suppose that's the maximum you could go, kind of 6 in the morning, without having to push cows out of paddocks, like.
Okay. Jordan, a question the same towards you, I suppose. How are people managing bulls on robot systems? Is it all, or is it just all AI with collars?
In general, there's probably most people do about between 3 to 6 weeks AI, and then they'll switch to bulls. Most people put collars on bulls. Some people don't, and the bulls just run with the cows anyway. Daithí, what did you do last year? Was it all AI, or are you doing?
No, yeah, we ran a bull at the end. We did try him without the collar, but he was an older bull and he just wasn't fast enough, so he couldn't get out after the cows. So we ended up putting a collar on him. They don't make collars big enough for him, so we had to put 2 collars together to get around his neck. But that was it. Just put it in, and you tell the system that he's a bull. So whatever grazeway he goes to at that allocated time, they'll let him out.
Okay. I don't think we have a whole lot more now. To be fair, we've covered a lot there in the last hour and a half. So I'm conscious not to keep everyone any longer if there is no further questions. Yeah, look, I'd say from our side of things, a lot of my job and a lot of Jordan's job is going out to farms and seeing, walking farms, looking at farmyards and seeing if they are suitable, giving an idea of building work that has to be done. So if there is, if that is something that interests someone, feel free to reach out, and we'll do our best to get out and have a look and see if it is an option, give you an idea of what the project might come to, or what the project might cost. But I'll just finish by thanking Arthur, Bertie, Jordan, and Daithí for all the effort that you put in over the last couple of weeks to get this pulled together, and Grace, who did a lot of work in the background on it too. So thanks very much for everyone. And if you have any questions or anything, feel free to reach out to ourselves or reach out to the lads at Grasstec, and we'll be happy to help.